Hey guys, so second video on exponential growth and decay functions. This focus is on exponential models, okay? So we already know the difference between growth and decay. We know growth are your bigger numbers, bigger than 1, decay your smaller ones, less than 1. So exponential models are actually very well used in the real world, whether you realize it or not. When you put money in a bank, it will exponentially grow at a certain rate, and we'll talk about that. And when you buy a car, it exponentially declines, unfortunately. The moment you drive off that parking lot from that dealership, your car no longer is worth whatever you paid for it. So we're going to be taking a look at exponential models throughout this. So first thing is, well, what are these models? So you have your growth model, which means you're doing 1 plus a number. Decay model, 1 minus, which should make sense because a growth has to be bigger than 1, so you're going to add the rate. Decay has to be less than 1, so you're going to subtract it. Okay, so things to be aware of. A, your initial value, initial amount of something. Maybe it's the initial amount you bought the car for, or it's the initial amount of money you put in the bank. That's your A value. T is the time, so how much ever time has passed. Usually it's in years. Y is the amount left after said amount of time. So whether you grew or decay depends on the problem, but it's the amount of money that you're left over with. I shouldn't say money. It should be the amount of whatever. Maybe it's a population. Could be money. Could be the size of something. Okay. But it's the amount left after time. The 1 plus R and 1 minus R, those are the factors. And I kind of remember it because it's in parentheses. Remember when we factor things, we put them in their groupings, in their parentheses. So 1 plus R is your growth factor. 1 minus R is the decay factor. And the R is the rate. So whether it's a growth rate or a decay rate, just depends on the problem. But R by itself is the rate. 1 plus or 1 minus it is the factor. And the thing to know is make sure you change the rate into decimals. Okay, so that's going to be a big thing. They're going to give it to you as a percentage. You need to change it to a decimal. So just know you're going to move the decimal place 2 spaces to the left, or you could just divide it by 100, whatever's easiest for you. So we're going to go through a couple problems together on here. We're going to start with this one, and then we'll move into the money, and that'll be it. Most of these problems, like I said, we'll go through in class, but I do want to have these on video for you to go back and reflect on. Okay, so it says the value of a car in thousands of dollars can be approximated by the model y equals 25, 0.85 to the t, where t is the number of years since the car was brand new. Okay, so since the car was bought. First part, tell whether the model represents exponential growth or decay. So that's going to be the parentheses part you're going to look at. And this one, it is 0.85. It is less than 1. So that tells me this is a decay model. All right, if it was bigger than 1, then I know it's a growth. So I'm going to keep that in the back of my head. I know I'm going to have a 1 minus R situation here. Okay. So it says identify the annual percent increase or decrease of the car. Well, I already know it's a decrease because it's a decay. And again, the fact that I want to use I want to find the percent, that means I want to find R. So all I'm going to do is take 1 minus R, that's my decay factor, and set it equal to the value of the decay, 0.85. And all you're simply going to do is solve for R. And we should all know how to solve for R here. You're going to subtract 1. You'll have negative 1 equals negative 0.15. Divide it. R is 0.15. So this is a 15% decrease. Make sure you answer the question. Don't leave it as 0.15. Don't leave it as R equals. You're going to tell me what it is. It is a 15% decrease in value. Okay. Part C, what was the original value of the car? Okay, your original value is your A. So the A in this case is 25. Well, does that make sense for a car to be $25? No. Go back, read. It says it's in thousands of dollars. So the original value is $25,000. So when you bought the car, you paid $25,000 for the car. Now, the last part says, estimate when the value of the, that should be car, not coin, will be $8,000. So all you're going to do is take 8,000, plug it into the Y. That's going to be the end value you're looking for. Okay. Now, we don't know how to solve this. We do not know how to solve for t in exponential part. However, we can use Desmos, we can use our graphing, our table function to help us out with this. Okay, so I'm going to actually have to clear all this out and get out of here. And if we go in, we're going to make a table, just like we did in the previous problem, make this just x. Going to change y equals into the equation we had, which was 25, 0.85 to the x. Now we're not going to do negative time. We start at time 0 when we bought the car. I'm going to do 1, 2. I'm going to keep going. And remember, I'm looking for when it's $8,000. But remember, it's 8, not 8,000, because the y was in thousands of dollars. So actually, when I set up that previous problem, it should have been 8 equals, not 8,000. And when I look, well, at 7, right here, it was about 8. It was slightly over, very slightly over, but that's pretty close enough for us to give an estimate. So when I go back, I can say that for 8 equals 25, 0.85 t, that t is about 7. So in about 7 years. Okay, so again, we can use that table feature of the Desmos, just keep hitting enter, finding it, estimate when it might happen. Okay, let's talk about the next problem. So the next problem now, we are going to create the model. Okay, so it says that we have, in 2000, the world's population was about 6.09 billion. During the next 13 years, it increased by 1.8%. So these are all numbers we're probably going to be needing. It says write an exponential growth model in billions. So I don't have to worry about adding all the zeros. T years after 2000. Estimate the population in 2005. So first we need to create the model, then we need to use the model. So let's create it. Remember, it's saying it's increasing, so that's going to be a growth. So I'm going to use 1 plus r, that growth model. Your A, remember, is the initial, so 6.09. That's where it started. The rate is your percentage. So now 1.18%, we're going to move that decimal place 2 over. So it becomes 0.0118 to the t. Okay, you're going to add it together, clean it up. And there's your growth model. Okay. The second part says estimate the population in 2005. Well, 2005 is how many years after 2000? Well, it's 5 years after the year 2000. And again, remember, we're starting at 2000. That's what they told us. So we're going to use this function. Putting in a 5. And this is just calculator work from here. So if I pull up my Desmos calculator or a calculator on your phone or whatever it is that you're going to use, you're just putting it in a calculator and you're going to estimate it's going to be about 6.46. I'm giving 2 decimals back because that's what we started with. Start with 2 decimals, so round to 2 decimals in your answer. So the population in 2005 is about 6.46 billion people. Okay. And in the last part, it says estimate the year when the world population was 7 billion. So just like we did before, we're going to have 7 equals our function. Okay, we're going to leave the t blank, and we're going to go back to Desmos. So again, I'm going to have to clear this so it's not all over the screen. Go back into Desmos. I'm going to change this to our new function, 6.09, 1.0118. GX. Okay, so here's all 6s, right? 8, 9, 10, still going. There we go. There's our 7 that we're looking for. So it takes about 12 years for it to hit 7 billion. Okay. Let's take a look at this one. Cars. We all like cars, right? I know it's a big thing in people's minds, especially teenagers. So let's talk about creating a function and using it for the car. So we're given this table. So year 0, when you bought it, you bought the car for $34,600. After a year, it's now worth $34,254. After 2 years, it's now $33,911.46. Okay, so let's actually ignore year 2 right now. We're going to make year 1 and 0 our goals. It's going to make our life really easy. So first thing is we got to come up with the rate. Well, what is the R that's happening here? So let's write down, I know it's decreasing. It says depreciating. That means it's decreasing. So I'm going to use this formula. And I have 2 values that I'm going to use here. This is at time 1 year 1, which is what I want to use. And this is my A value. It's my starting. It's what it was originally at. So I know my AA, I know 1, and I know what it equaled after year 1. So I'm going to put all that information in here. So 34,254, that was the Y value when time was 1. A was what I paid to start, the initial cost. 1 minus R, that's what I'm trying to figure out. And T is 1. I'm just going to make your life so much easier as we go through and try to solve this. Okay, when T is 1, that means there's nothing happening with that parentheses. I don't have to worry about squaring it or cubing it or doing anything extra. All I have to do really is divide, get rid of this. Okay, you would just put that in your calculator, right? When you do that, you end up with about 99.99. 1 minus R to the first. Now, it's first power. I don't even need to write it. I can erase that out there. 1 minus R, I need to find out what R is. So I'm actually going to get rid of these parentheses too. We know how to solve for R. All right, minus 1. And then divide. So we get R equals 0.01 or 1%. So it's a 1% decrease. That one's not too bad. Okay. So to write the rule, now they want us to use A and N for our years. So we got to follow what they say. So this is going to be a capital A. This is going to be an N. That's what they're asking us for. Okay. So A equals, we know our initial value, 34,600. 1 minus 0.01 to the N power. Or you can change that to the 0.99. Either or, up to you. And then the last part says, well, assuming that it stays constant, so assuming it's still going to decrease by 1% each year, what is it if you sell your car after 10 years? Give your answer to the nearest cent. So you are simply going to use 10 for your timeline. Put a 10 in as the exponent, put it in your calculator, and you're going to find that it is about 31,254 $1,291.62. Okay, and that's your depreciation. So it's decreasing by 1% each year. At 10 years, you can see the difference in what it's costs. All right. Last thing we're going to take a look at, money. We went from cars, people love cars, people love money. So we have what's called a compound interest model. So this is used in banking. So it's A amount over time equals P, which we call the principal, or the initial amount that you invest or put in the bank, 1 plus R over N to the N times T. So it's R over N because you're taking your rate and you're going to divide it by however many times they're compounding or they're looking or they're adding interest to your bank account. And then in the exponent, N times T, your time frame, your years times however many times they're compounding your money. And I have over here just a couple. These are the common ones you're going to see. It can be compounded daily. So N would then be 365 days in a year. Monthly, your N is 12 months in a year. Weekly is 52 for the 52 weeks. Annually is one year. Quarterly is four times a year. Biannually is twice. There are some other ones. These are your basic ones that you're going to see. Usually you'll see daily, monthly, weekly, or annually. All right. So let's do an example with that, and then we'll be done with our models. So first thing, let me move myself out of the way. Says we're depositing $9,000. Let me get my pen out. All right, so we're depositing $9,000, tells us the rate. So there's my R. This is my principal amount that I'm putting in. It says find the balance after 3 years. So now I know a time frame. When the interest is compounded quarterly, and then we're going to do it again daily. So quarterly, that's when N is 4 quarters in a year. Daily, our N is going to be 365 for 365 days. Okay, so let's go back real quick. I'll write down the formula. So A equals P 1 plus R over N times T. Okay, so again, as we're going through this, that's going to be our formula. Our money's going to grow. So we're going to have the growth formula. We're adding to it. All right. And simply just going to fill in everything we know. We're looking for A. I know P is 9,000. 1 plus rate. So 1.46 is really 0.0146. Move the decimal. All over N, which we said was 4 for the quarterly. And then N times T, so 4 times 3 years. And you're going to put this in your calculator. What I suggest you do, again, it's clearly all up to you. I tend to figure out the inside first and then just make it smaller from there. So what I would first do, put in my calculator 0.0146 divided by 4. When you do that, you're going to get 0.0036. 4 times 3 is easy. That's 12. Okay. And then you can put that in your calculator. You can add the 1 to it. This is a little bit easier to put in the calculator than that whole long thing. So it's just my suggestion for you to chunk it down, do it in pieces first. And when you put that in your calculator, you're going to get about $9,396.59. Again, make sure you're rounding it to your penny. Don't give me all these extra decimals. You only want to round to 2 decimal places when you're talking about money. Compounding daily is the exact same thing. The only difference is that we are going to use 365 instead of 4. Because now instead of doing it 4 times a year, we're doing it every single day of the year. So that's 365 days. Actually, that should be a 3 over 3 years. Okay, again, I would chunk it down, put it in your calculator, make things smaller. So if I put in the fraction first, I get 0.00004. When you do the decimals from your fractions, at least 4 decimal places. This one, if I did 4, it would still be 0. So I bumped it back to 5. But I would say don't do anything less than 4 decimal places here. 365 times 3, that's also a big number. So that's 1095. And again, that would then go in your calculator if you wanted to add, the numbers together first. Move me. And that's going to be about $9,402.95. So I'm just going to bring myself over here and talk about that for a moment. If we compare these, it's really an $8 difference between compounding it 4 times a year versus compounding it 365 days every single day of the year. And $8 can add up, so don't mock it. But you'll notice that the more times it's compounded, it's not going to make you have this ginormous amount of windfall. It's just going to be an extra couple dollars, most likely, when you compound your money different ways. Okay, so hopefully this helped you out. We'll do a couple more examples in class. And you can always come to me if you have questions.